sure what species it is, but there you go. That's not the highest quality picture, but someone was found on an oak, didn't have a stalk. Just, oh yeah, there you go. Just growing directly into it was tiny.
Was that in Los Angeles?
Yeah, so this was in the same place as all these other mushrooms pretty much in Descanso Gardens. Yeah, I was surprised to find it because, well, I mean, it looks kind of exotic. I guess that's what mushrooms are, but I was surprised to find it. I thought it was kind of pretty.
Christian, do you have an ID for that? Is that like that strawberries and cream one or something?
It's definitely
different?
not strawberries and cream, but what it is, I can't say. It's some exudating with soup in it. Could be a polypore, could be, I can't see closely enough if it has pores. But there's actually a lot of crustose things that do these exudative droplets, and it's really hard to tell what they are without a little bit more close look. Could be a really young Ganoderma. I've never seen them exude like that, but Jess, you're probably more familiar with Ganoderma polychromum than I am.
Well, very good. I think we'll stop here and start the regular meeting.
Yes.
Okay. So, first question to the LAMS Council is, do we have any announcements? If not, I'll just tell people what's going on, which is one thing is we're trying to set a date for the annual meeting. The meeting has not been set yet, but the council is working on that. The other thing is that we have made the call for nominations, and nominations are still open, probably till about the first week in May. So anyone in LAMS is, welcome to put their name in to one of the council members' positions and to see if they get elected and to try and help be part of the leadership of LAMS. If not, the other thing I'd like to invite everyone to do is to consider other ways to get involved in LAMS. And we're hoping that when we, after we convene at this next meeting, that we have some opportunities for LAMS members to participate in different activities that we're doing. So I hope that you'll hear more about that in a LAMS email or in the spore print in the not too distant future. Anything else from any of the council?
I was gonna say, I'm gonna link it in the chat, but this week just started. You can vote to nominate which mushroom you think should be the California state mushroom. And that's the link. California has a state lichen, but not a mushroom. So this is really exciting. I won't say my opinion yet.
I'll say mine. You should vote for jack-o'-lantern.
Yes. I mean,
I think I'm far enough away from the polling places that I'm allowed to campaign still. So jack-o'-lantern is the reason I think jack-o'-lantern is a great choice for the state mushroom is that it occurs pretty much throughout the entire state. So everyone in California has a chance to see it, unlike some of the other choices, which are like very much Northern California mushrooms. Another reason is that it's almost endemic to California. So it only barely goes over the state boundary into Oregon and Baja. So it fills the state, but barely exceeds it. It's like the best mushroom you could choose to like outline the California boundary. It's also just really cool. It glows in the dark. It dyes wool purple. And it's really pretty. It recycles oak trees and other hardwoods throughout the state. It's got a nice ecological role. It's not just interesting from an edibility perspective. So My nomination, it's actually not my nomination. Elsa Valinga was the one who came up with the idea, but I am certainly a partisan for it.
Excellent, thank you. Yeah, it is an interesting mushroom. So you might get my vote.
Yeah, mine.
Counting on it.
Yeah. Oh, and I'll announce also for the reading group next week, we have our final discussion on braiding sweetgrass. I've been lagging on the email, so I'll send that out tonight, and we'll be discussing restoration ecology and how fungi can incorporate that through Robin Wall Kimmerer's perspective. And on May 2nd, we'll be following up once again on Merlin Sheldrake's chapter, Radical Mycology, and he talks about mycomaterials. And we're going to have a local person, Sam Schumacher, talk about his experience with mycomaterials too. So yeah, come join us, Arlington Gardens in Pasadena, Mondays at 7. I'll link those in the chat.
Someone pointed out that Omphaliotis is color coordinated with California poppies, and I think that's a brilliant insight.
Aaron, do you want to introduce tonight's speaker, since you've been the chair, this acting chair?
I sure can. Here we go. So excited for this one. So we have here Christian Schwartz tonight, the co-author of Mushrooms of the Redwood Coast, my favorite ID book. Christian Schwartz is a naturalist currently living in Santa Cruz, the land of milk caps and honey mushrooms. He studied ecology and evolution at UCSC and now spends his time photographing, teaching about, collecting, and researching macrofungi. He is co-author of Mushrooms of the Redwood Coast, a comprehensive guide to the fungi of coastal Northern California, but also a lot of ours. Fungi satisfy his curiosity with their seemingly endless forms, from the grotesque to the bizarre to the sublimely beautiful. Besides dabbling in mushroom taxonomy, he loves fish, plants, nudibranches, moths, and dragonflies. He's passionate about community science, especially iNaturalists. So let me welcome Christian Schwartz, talk about mushroom bioregions of the United States tonight.
Thanks, Aaron. I wish I could be amongst you all in person rather than on Zoom. I thought I was never gonna have to do one of these again. Hopefully this is the last one. Are you guys getting any rain right now? It's raining in Santa Cruz, which I'm very excited about. I hope some of it blows your way. But the reason I mentioned that is because I am actually from San Diego originally. So I feel this sort of affinity or kinship with Southern California mushroom clubs. The San Diego Mycological Society was the first club I was ever a member of. And I know what it feels like to be dry when all the rest of the state is wet. And to wish that your mushrooms were fruiting. And that was actually like one of the probably original reasons I got interested in the biogeography of mushrooms. So biogeography is sort of a self-explanatory term, but just to outline it, it has to do with where things live spatially, where on a map you find different species. And this is one of the sort of big sub-disciplines of ecology and biology. You find people studying biogeography in every group of organisms. So there are people who study the biogeography of birds, people who study the biogeography of flowers and plants, but there's actually relatively little studied about the biogeography of fungi for a lot of reasons that you're already familiar with. Some of the reasons. We don't know them as well. We have relatively fewer people working on them at all. So you have just a smaller body of academic researchers who might be available to study biogeography. But they're also sort of complicated. They're hard to find a lot of the time because they are present as a mycelium, but not as fruit bodies. So it makes them difficult to detect. You can't easily say whether or not a mushroom is actually absent from a place without a lot of work. So it's hard to prove the absence of species. And it's even sort of difficult to prove their presence because they're so ephemeral. But I am really excited by the idea of getting to know more about the biogeography of mushrooms. It's probably one of my favorite topics to think about within mycology. I'm interested in learning to identify them, of course, but that for me has always felt like a starting point only, with the idea that learning their names allows you to recognize characters on a play that's in a play that's unfolding, whether that's their ecology, so interactions with each other and with other organisms, or whether it's sort of biogeography, which I'll just start sharing my screen now, and we can just get into this, because some of what I want to say is better illustrated by slides. Okay. So not all of the images in the talk tonight are mine, which is a little bit unusual. Usually I try and use mostly my own images, but because this has to do with mushrooms everywhere, there are many mushrooms that I have never seen that I want to show you tonight. And I try in almost every case to label images that are not mine with the author's name or the photographer's name, but it looks like a few of them were stripped out of the talk. So I will try and point those out where possible if I'm missing them, but just so you know, they're not all mine. For example, on this first title slide, that one right in the middle with the drip coming off the edge of the cap is not my picture. That's a really cool bolete that I want to see someday, but I will tell you the photographer's name later when I profile that mushroom more individually. But the other ones on this title slide I have seen, and they're all sort of representative of some of the bioregions that I'm going to talk about. So let's just get into this. Okay, how do I, there we go. Okay, so here's our substrate, our starting point. Mushroom bioregions of the United States. Now you might ask, why did I choose the United States? Is it because I am the most patriotic person you've ever met? The answer is definitely not. I chose the United States because it's where I happen to live and where I happen to work and where it's easy for me to get around. And that's it. It's a useful way of narrowing my attention, not because I don't care about the fungi of Mexico nor of Canada, because I'm interested in both of those things, especially Mexico. My mother's Mexican. I spent a lot of time in Mexico. So I actually am really interested in the mushrooms of Mexico and how they interact with mushrooms in the United States. But for the purposes of having some way to narrow our scope and make life a little easier on ourselves, I just choose this arbitrary political boundary. And it turns out that it does align in some ways with interesting natural biogeographic boundaries. And I'll talk about what that means in a second. But what do you suppose this map shows us? What are the different colors corresponding to here? And you can all feel free, there's only 36 or I don't know how many there are, not too many. You can turn on your mics and just interrupt me when I ask a question, or if you have a question. What are these different colors?
It looks like elevation.
Exactly right. It's elevation. And there's a couple patterns that I want to point out here. There's not a whole lot of elevation in the east. There's a sort of a smudgy band running from Maine down through New York, down through sort of the states away from the immediate coast along the Atlantic and into North Carolina. And those are the Appalachians. So for those of you who are not familiar with them, that mountain range over on the right of the country that runs sort of north-south diagonally is very, very old mountains, but they're low and they're eroded down pretty low. They are not like the mountains you find in the West, especially here in California or Colorado, which are tall and jagged and craggy and relatively uneroded, and they rise much, much higher. But let's take a look at the West now. There's that big blob of orange right in the middle of the country, or just west of the middle. Those are the Rockies, obviously. And then you see sort of a stripe of orange running north-south on the eastern boundary of California. That's the Sierra Nevada. And look what it does to California. It isolates it, and it makes that big green depression of the Central Valley even more pronounced by contrast. There's a high band right next to a low band, and it makes California a little bit of an island. And I'll talk more about that later. But one last thing I want to point out about this elevational map is to look at the center of the country. You see that pale beige band that actually is not aligned with the Mississippi. People often think about east of the Mississippi, west of the Mississippi as being somehow a dividing line in the country, and it is for some organisms. But for mushrooms, this north-south band that comes from, I don't know, I guess the Dakotas down through Texas, that is a much more important band from a biogeographic perspective. It corresponds with a rainfall band as well. So there's a big shift in how much rain falls east and west of that line. And there's a big shift in the elevation east and west of that line. So it ends up having a big influence on the patterns we see in mushroom distributions. Okay, so this is that same area, the United States, or at least the continental United States, but now we've got the colors representing rainfall. And you can see that that band is virtually the same. The temperature and the, or sorry, not the temperature, the elevation and the rainfall kind of reiterate one another. And that's not coincidental. Rainfall is sensitive to elevation in many ways, but this strengthens that pattern that I was just talking about. Something that's super important to notice here is the orange and red along the south and eastern boundaries of California. That emphasizes or reiterates or strengthens the island nature of the coast. The coast of California is isolated from the rest of the country by this sort of big natural barrier of heat and low elevation in Southern California, and then dryness and high elevation in Northern California along the eastern boundary, that is. So these are sort of the patterns that we can think of being influential to where mushrooms can make a living. Like any organism, they're sensitive to these abiotic variables. So when I say abiotic, I mean not having to do with other living things. Rainfall, elevation, soil chemistry, these are things that don't necessarily have an origin in life, in something living, but they influence living things. And that's one side of the biogeographic equation. Another side has to do with biotic influence. And what I mean by that is, as you all know, mushrooms are strongly constrained about where they can live by the trees that they need to partner with or that they need to grow with. They're living partners. Not every mushroom obviously requires a tree to make a living, but in many cases, vegetation is going to be a strong explanatory variable in the patterns that we see. And that is sort of what I want to show in these two maps. So once again, this is the North American continent north of Mexico. And there are different ways of divvying up this political bounded entity that we call Northern North America into more biogeographically meaningful blobs that we can call bioregions or biotones or ecozones. There's sort of an endless number of nouns that scientists have come up with to attempt to describe these ultimately artificial boundaries, circumscribing what feel like recognizably different units of organisms. So the goal here is to not name these totally arbitrarily, but to represent something that feels different and distinct and maybe has some sort of reality in the boundedness, the reason that all those organisms are there and not elsewhere. And you can either divide very finely and you end up with, all of the different bioregions you see on the right, or you can divide very broadly and you end up with just a few bioregions like you see on the left: the Arctic, the boreal forest, Cascadia, Dixon, Sonora, California. And both of these have their strengths and limitations, obviously. The more finely you divide the map, the more you can get those blobs to correspond with something really unique and real and small scale and fine grained, and it's more descriptive, but it's also really unwieldy. There's so many. I think there's 140 different bioregions represented on the map on the right. So that's just kind of too many. That's so many that you can't possibly sort of memorize them all easily. Whereas on the left, you have some really general descriptors, and maybe they obscure some of the fine variation, but you can easily get a handle on them just studying them for a few minutes. And you can guess what they correspond with, and more or less what they'd feel like, even without being super familiar with them, unlike the finely divided map on the right. And what I want to aim for here is something that is a little bit in between both of these. So tonight, I'm going to be talking about proposed putative potential bioregions that are important for mushrooms in the United States, that are a little bit more fine-grained than what you see on the left, but much less fine-grained than what you see on the right. More or less at the level of states or a couple states together. But I want to emphasize two things. A is that all of these bioregions are human constructions that are intended to summarize and allow for communication about organisms and what it feels like to be in a habitat in a certain place, but they're not real from the organism's perspective. There is no objective or permanent or fixed reality to any of these. They're always blurry at their edges, and they always shift through time. So none of these are permanent. None of them are stable forever. As we'll talk about, where organisms live on the map is also highly intertwined with time, deep time. So ancient stories about geology, about landscape morphology, and about evolution and ecology are reflected in the patterns we see nowadays, but they are not fixed. They're not static. The second thing I want to re-emphasize is that what I'm going to talk about tonight is stuff I've come up with on my own that's completely a first pass guess. It is just my estimation about some of the bioregions that we could potentially consider important in the United States. I think the more we study this, the more we're going to refine what I'm talking about tonight. Some of the things that I talk about will probably be thrown out entirely and replaced with other conceptions of what bioregions are for mushrooms in the United States. Many will be added. They will hopefully get to a level of refinement that maybe we approach something like what you see on the right, but we're a long way from that. So I want you to take everything I'm saying with a big grain of salt and just, perceive what I'm talking about tonight as the ramblings of someone who is interested, but not necessarily in any way an expert on this. Okay, so the question we're going to focus on is, what are the major mushroom bioregions of the United States? And right there in the question, you can tell that there's no definition to what major means. What does major mean? It just means the important ones. And one way I often think about this is, if you had won the lottery and you were a real mushroom nerd, hopefully one of us gets to live out this fantasy I'm painting, where would you go? What are all the places you would want to visit to see all the cool mushrooms of the United States? What would be sort of the best bucket list trips that you could plan for yourself to go find a representative sampling of mushrooms that make the United States special? And so it's, in a sense, I basically just am putting together a list of destinations for myself, places that I want to go to see interesting mushrooms. So let's start. Envision in your head the map of the United States. In the upper left-hand corner, the northwest, the extreme northwest. And I will talk about Alaska because that is not only objectively one of the 50 states, but it is an important one because it acts as a stepping stone to Eurasia. And what I mean by that is that it is so far north and west that it almost comes into contact with the westernmost extent of Kamchatka, or sorry, the easternmost extent of Kamchatka, which is that Russian peninsula. And it allows potentially for crossover of Eurasian species into North America by this close approach of the two land masses, one to another. And that's in fact what we see when we go to Alaska and we look around in the woods there. What we find are mushrooms that in some cases are much more like what you would expect to find in Europe or Eurasia. There's in the middle there, Amanita muscaria, everyone recognizes that, but in Alaska, I will note that the muscaria that you find don't necessarily feel like the muscaria that you find here in California. They have a different color to their partial veil and universal veil, and they feel more like the illustrations of the variant of muscaria that you find in Europe. And I think genetics has borne this out. Joseph Gemmell did quite a bit of work on the different genetic lineages within muscaria and found that the ones up in Alaska are quite different from the ones you find here in California. Rustula consobrina, this gray-brown rustula down at the bottom left, that is not something you find really anywhere lower in the States. Maybe you find it across Canada, but I haven't had enough time to visit there or look through records to see if it's present there. In the middle, in the bottom row there, that's Hypocreopsis lichenoides, this weird wrinkly sort of Shar-Pei looking crust that grows on branches. There is one species that also grows in the Appalachians in the same genus, but this is a mushroom that you find in Finland, where they call it troll hand. That's the common name for this mushroom. It's a really special thing that you don't see elsewhere, or at least it's not known to occur commonly elsewhere in the United States. But you also see things like Cystotrema, which is this weird toothy chanterelle relative at the upper left here, growing with the birches. It's got a really intriguing smell to it. I'm certain it's edible. I can't wait for someone like Stu to incorporate it into food and tell us what it's like. Down at the bottom right, we've got Plicoteropsis, this cute little non-polypore. It's actually got veins, but it looks almost like turkey tail. And that's a mushroom that you see all over the East Coast. And the reason that you see it all over the East Coast and in Alaska is the continuity of the birches across the northern part of northern North America. So this is an example of a mushroom, this little one on the bottom right here, that follows its host around more or less. It is mostly determined by its biotic influences. So interaction with other organisms is what describes the pattern that we see in its biogeography. The upper right there, I won't dwell on it too much, but that beautiful yellow thing is actually a waxy cap relative that I found growing right on the edge of this giant glacier that was in this first image. So where my mouse is hovering, there's a little patch of mosses and very low bushy plants. And it was the last mushroom that I saw before the edge of the ice field. So it was a really striking habitat to find it in. There were no other mushrooms around. You can see these little patches of green here on this rock field, and it was making a living there somehow. I don't know why. But mushrooms are inscrutable. What can I say? Okay, so we moved down from Alaska along the Pacific seaboard and into the next zone that I want to talk about. And this is actually the topic of my next book that I'm writing with Noah Siegel is Mushrooms of Cascadia, Mushrooms of the Pacific Northwest. And what I mean by Cascadia is this biozone that's this name Cascadia has actually been used since about the 70s for the falling waters region of British Columbia, coastal Washington, Oregon, down into Northern California even. But this is truly one of the richest biozones for mushrooms in North America. I think that no matter what changes about our understanding of mushroom bioregions, this is going to be one of them. Cascadia has sort of a meaningful circumscription around it that means that its mushrooms are sort of coherent and different. So I'll talk about a few of them here. There's a lot of things like coral mushrooms, a lot of Ramaria diversity in this part of the world. There's a lot of Cortinarius. That one in the lower left there is Cortinarius anthracynus, kind of purplish and pink and green. And it's an example of a species that actually has continuity through Alaska to Europe. So Cortinarius anthracynus is a species that, or at least something that looks very, very similar to it, genetically very similar to it. We're not sure whether or not they're actually diverged into what we would consider separate evolutionary lineages now, but something has made its way from Europe into coastal California, even far northern California, through this Cascadian bioregion and its connectivity with Alaska. Phaeocalybia, that tapering root mushroom on the upper left there, super diverse in the Pacific Northwest. We do have some species in California. In fact, quite a few if you go up to Humboldt, but they really start to taper off as soon as you get further south in our state. Here's an image in the bottom middle by Corndog is his username on iNaturalist. His real name is Connor Dooley. He's an amazing photographer. And this is a funky little mushroom called Squamanita. And it is one of the coolest mushrooms in the entire world. It is a body snatcher. It is a parasite fungus that grows into the fruit bodies of other mushrooms and takes them over and replaces their caps with its own cap. And so it's got these purplish gray surfaces. It smells like grape candy. And it's this completely distinct, unique ecology that no other mushroom shows. It's super rare. I have never seen it. There's only a handful of people in the world who've ever seen it. It's actually one of the rarest mushrooms in North America. It was first recorded from Alaska in 2019, I think. And then it was found a couple times in Oregon last year. In total, I think there are only about 6 locations known anywhere in the world for this mushroom. 3 of them are in Eurasia, 3 of them are along the Pacific seaboard of the United States. So Oregon and Alaska currently known, probably in Washington somewhere as well. There are some relatives as well in British Columbia, but this is an example of just something so Cascadian, these very wet coastal forests dominated by conifers that are so abundant throughout Oregon and Washington and British Columbia host real treasures like this. The Amanita you see over on the right is a lepidella, and it's really not, Amanita are not very rich in the Pacific Northwest compared to the East Coast, but the reason I include it is because there's a totally distinct set of Amanita that you find along the Pacific coast. Very different from what you find in the East, even though the Eastern United States is really the core diversity of Amanitas in North America. A mushroom that probably would be the best state mushroom for Washington to choose. That's a hint for any of you Washingtonians or who have relatives up there, get the movement going early and get it off on the right foot, is Polyozellus multiplex, sometimes called, actually it's no longer multiplex, it's called the blue chanterelle sometimes, because it looks like a chanterelle. It's got these veins and ridges and wrinkles, and it's sort of funnel shaped like a chanterelle, but it's not at all closely related to chanterelles, but it has this amazing deep indigo to navy blue color all over the slopes of Mount Rainier in the old growth forest, but really hard to find elsewhere. There are about 6 species of Polyozellus across North America, but they are only in places where there's wet old growth conifer forest. That is what they like. I've only ever seen it in Washington on the slopes of Mount Rainier, but there is 2 old records from far northern California. No one has seen it since, I think, what was it, the 80s when they were last found. And if they are proven to still exist here, it would be sort of evidence of a continuing linkage between the Cascadian biozone and far northern California, which is going to be the next region I talk about. But one last species I want to talk about that is emblematic of Cascadia is the noble polypore, or Bridgioporus nobilissimus. This is a photo by a user on Mushroom Observer called Angus. Beautiful photo of this incredible species. For those of you who don't know, this polypore can be 3 or 4 feet wide and 3 or 4 feet deep. Absolutely enormous fruit bodies, only growing on old growth grand fir. Probably one of the largest fruit bodies of any mushroom in the United States. The cap is covered in this deep carpet-like covering of fuzz that often hosts a whole community of lichens and even other mushrooms. There'll be mycenas growing on top of these polypores, and algae turning the older caps green. But it's a super rare polypore. There are only about 100 known localities, and there are fewer every year because grand fir is sort of dying out in a lot of places, at least the old growth grand fir, and it needs these old growth stumps in order to grow. There was one fruit body known from far northern California that I went and visited in 2010. No, sorry, 2009 perhaps. I forget what year I went. It was in Humboldt Redwoods National Park. But unfortunately, some tourists sat on it and broke it off the stump that it was growing on. And so it sort of died and rotted, and it hasn't really produced a new fruit body again yet. But the reason I point this mushroom out is that when you look at the range map, the points that it occurs on iNaturalist, it sort of perfectly outlines the region I'm talking about. And this is a repeated pattern that I want to try and do, is when I propose a bioregion, I want to find a species or a group of species that naturally outline the bioregion I'm talking about. I don't know if that makes sense, but the goal is to find an indicator species or an emblematic species that outlines the bioregion that I'm proposing. So here's one that does a pretty good job of showing you where I mean when I mean Cascadia. Okay, so now we move south into our zone. And for convenience sake, I sort of characterize California as being of 2 flavors: Northern California, the redwood zone, and Southern California, the live oak zone, because these are the 2 trees that make California most distinctive of all among the bioregions of fungi in the United States. The redwoods bring with them a whole host of species that are distinct from anything you'd find anywhere else. You get these green earth tongues, you get these blue leptonias and entalomas, you get the amazing waxy cap diversity, especially around the Bay Area. But you also get agaricus with redwoods and cypresses as well. That's another group of trees that really lend us some regional flavor. But then down south, like where you are in LA and in San Luis Obispo and San Diego, even into Santa Cruz to some degree, the live oaks and all of their mycorrhizal associates are what make our area so special. You get green cortinariuses and distinct boletes from anywhere else in the country, all associated with this amazing mycorrhizal host that we call the live oak. It hosts hundreds and hundreds of obligately associated species. So these are the two trees that make our zone special. I mean, two representative trees. They're not the only things that make our zone special. For example, if you go up into the mountains, you don't find either redwoods or live oaks, but what you do find is snow. And the Sierra Nevada and Cascades mountain ranges that extend into far northern California and run all the way south to Sequoia National Park are home to this assemblage of species that respond to melting snow. And this is one of the things that makes California, and to some degree Oregon and Washington as well, but really California especially, very distinctive, is having the snow melt assemblage of mushrooms. Some of these include these little black cups up the top here, Donadinia, the snow melt foliota, that's gastroid, that's the middle upper row there. It smells like wintergreen mints. Totally amazing species, really strongly associated with the edges of melting snowbanks. Lachnellula arida, that's at the upper right, Mycena overholtzii, Mycena nivicola, and this snowmelt crepidotus on the bottom left. These are species that have evolved this response pattern to the sudden influx of water that comes off of melting snowbanks in the spring. And what's amazing is that even in other parts of the world that have snow in the mountains, you don't get a distinct snowmelt associated fungal flora, and that's unusual. And there's a few hypotheses that have been proposed for why California has this pattern, but whatever the reason is, they really contribute a lot to the distinctiveness of the fungi that live here. So if you are lucky enough to live near mountains where there's melting snow reliably, definitely go seek these out. Go try and experience this interesting part of California's mushroom flora. And I'll point out that this Hygrophorus getzii, this pink waxy cap that grows at the edges of melting snow, you're not going to find it in Southern California because it's associated with mountain hemlock. So you have to go pretty far north up to Mount Shasta or Rainier, that's up in Washington. You can find it there as well. Mount Lassen is where I took this photo. This is probably one of the more endangered fungi in California, and the snowmelt is interesting for that reason as well. Climate change is making it so that there's less deep snowpack on average every year, and that it melts faster. And that has a direct impact on the ecology of these snowmelt associated mushrooms. If that snowpack doesn't accumulate, and if that snowpack melts really quickly, they don't get a chance to respond in their normal timing, their normal pattern. So I think things like this Hygrophorus are actually quite at risk of changing climate regime. So these could be some of our more, I mean, there's not much to do conservation-wise. You can't reverse climate change to the scale that it would impact this, but these are the kinds of mushrooms that we need to keep on our radar as conservation concerns. All right, so moving inwards, we're now skipping over from the mountains across the desert. So now we've separated California from this biozone by the Bazinen Range, the high desert, the dry interior west. And now we're in the Rocky Mountains. So in between, what happened? I just skipped over it because from a mushroom's perspective, that is a huge ocean. It is a barrier to dispersal for most species. There's not a lot of mushrooms that can make a living on the coast of California and in the Rocky Mountains and in the dry desert that separates them. There are some species that can disperse over this boundary, but for many species, it represents a really serious barrier to dispersal that they can't cross. So what do we find in the Rockies? Some of you who've been to Telluride are lucky enough to have experienced some of these landscapes and some of these mushrooms, but we see this race of porcini, or this variant of porcini. Boletus rubriceps is its current name. There's some thought that it will be actually demoted back to a variety name or subspecies because it's barely different genetically from our coastal California king boletes, but they look really different. They have a very different feel to them. But you do see some of the same mushrooms that you see in far northern California, like this Alloclaveria purpurea, this beautiful pink coral, or sorry, purple coral mushroom. But this is a zone largely dominated from a biogeographic perspective by the influence of cold winters and aspens and conifers. So you get not too many other hardwoods, but you get these big aspen forests at high elevation. And so you get things like the lexinums with the aspens and the cottonwoods. You get matsutake with the conifers. And these matsutake, it turns out, are actually quite distinct, but it represents sort of an overlap zone between matsutake that come from Mexico, that's Tricholoma mesoamericanum, and matsutake that come in from the east, that's Tricholoma magnivelare, and Tricholoma marillianum, which is our California matsutake. And you could end up potentially with 3 different species of matsutake depending on where you are in the Rocky Mountains. We don't know where each one is yet. We don't know if they're all 3 present, and if they are, we don't know how they divide that biogeography between them, or if they do, maybe they blend all together. But whatever the case, it's still something we have to learn. But the Rockies run really deep into northern New Mexico, and even Arizona. The White Mountains are basically an extension of the Rocky Mountains, and then they go all the way up into the far northern reaches of northern North America, and I'm going to talk about that area next. Something that you get in the high mountains and in, oops, did I skip over a slide here? Oh no, I think I'm just out of order. I want to mention this tree, larches, which you do get in northern Rocky Mountains, as well as in the boreal forest that crosses North America. These are a really specific kind of mushroom host. They're a conifer that loses all its needles. So they're a deciduous conifer, which is really unusual. And they seem to have, wherever they grow, a distinct assemblage of slippery jacks. And these are just a few examples. So the middle one is not my photo. That is from Walt Sturgeon, but the other 2 are my photos. Oops. And these larches are an example of one of the bioregions of plants that doesn't form, no one talks about the larch zone as being a special bioregion from a plant perspective, but I think from a mushroom perspective, larches sort of form their own unit or their own entity, because wherever they are, they exert such a strong influence on the associated mushrooms. All the slippery jack diversity that grows there and nowhere else. These are, for anyone interested, Swillus clintonianus, Swillus gracilis, and Swillus ampliporus, or cavipes. Some of the names are a little bit questionable at the moment, but these are the names that they go by for now. Okay, so many of you have probably heard me talk about the Sky Islands before, and this is a place that has totally captivated me for a few reasons, not least of which is their biogeographic significance. They are a major puzzle piece in the picture that we're assembling of where mushrooms live across North America. So for those of you who don't know, this term, the Sky Islands, refers to the phenomenon of high mountains emerging out of low desert in the southwest of the United States. So Arizona, New Mexico, to some degree, even Southern California, you could say, has a few Sky Islands. Palomar Mountain, for example, jumps to mind, the San Jacintos. Definitely Baja California could be said to have a few Sky Islands. Texas could claim to have a few Sky Islands. The Chisos Mountains definitely come to mind, but their core extent is really in Arizona. And what this is an extension of the Sierra Madre, the Mexican mountain ranges that run up the east and west sides of the Mexican country and barely cross the border into the United States. And these are just very tall mountains emerging out of very low desert. So it can be blazing hot, 100 degrees down in the bottom of the mountain range, and then it'll be 60 degrees up at the top and raining. So totally different weather at the tops of these mountains than you get down at the bottom. And within very few horizontal miles, you get a huge change in elevation, and you ascend through different bioregions and different life zones as you climb altitude. So in a way, it's like mimicking the north to south latitude of the whole country, but instead of doing it over latitude, you do it over elevation in a single place. But the story is more interesting than that even. Here are some of the mushrooms that you might expect to find in Arizona. And this is just, you know, an 8-hour drive or less from where you are in Los Angeles. And you're never going to find any of these mushrooms in Los Angeles. The turnover between Southern California and Southeast Arizona is complete. It's virtually 100% turnover. There are very few shared species, despite the fact that these two states are right next to each other. Their mushroom assemblages are about as different as you can find of two different states. So it's a really fascinating pattern. You can take that same horizontal distance anywhere else in the country and the mushrooms would be very similar. But in this particular part of the country, it experiences just a dramatic change. And part of that is because of the isolating impact of the desert that separates the eastern boundary of California from the interior of Arizona. But there are other reasons that there's real differences here. So we get these amazing boletes that are more typical of the East Coast. Butyroboletus frostii, it's the beautiful red thing at the upper left. Old Man of the Woods, Strobilomyces, it's the middle upper row. A different species of jack-o'-lantern. Some of you might have said, hey, isn't that our state mushroom there? No, it's not, but it's its nearest relative. This is Omphaliotus subilludens. It doesn't tend to turn green the way ours do in California, and it's got a bit of a different glow to it, so it's a slightly different species. And then you get all this bolete diversity, these species down at the bottom row. Some of them are endemic to the Sky Islands. So you actually don't find them on the East Coast. You only find them in these mountains that are the extension of the Sierra Madre in New Mexico and Arizona. And what's really cool is that you can find them growing next to these agave plants and next to cactuses. It just feels radically different from anything we're used to on the wet California coast up here where I am in Santa Cruz. You just don't expect to see mushrooms next to cactus. And this is definitely the kind of aesthetic delight that has sunk its hooks in me and makes me go back to the Sky Islands year after year. I like sweating when I find boletes. I like dodging rattlesnakes when I find boletes. The Gulf, oops. Oh yeah, I skipped over quite a bit here. How did that happen? Whoa. What happened? Sorry, it just like took me all the way through to the end. Hold on. I have to reshare this. Okay, back on track. Or is it back on track? No, it's not back on track. Sorry, guys. Okay, there we go. So there's another interesting thing about the Sky Islands that I'm not going to talk about right now because I want to cover some of the other bioregions, but I'll give you the outline of what it is, which is that there is an echo of Eastern North America in the southeast corner of Arizona. Even though you're much closer by air miles to California, the mushrooms that you find there are in many ways reminiscent of what you'd expect to find in Connecticut, which is very unintuitive. And we'll talk about why that is when we get to the range maps in a few minutes. Okay, so I'm just briefly going to address a few other zones that I'm not really familiar with, but which I suspect will end up being important bioregions in the final, whatever final means, in the eventual understanding, more sophisticated understanding of what are important places for mushrooms in the United States. One such place is the Gulf Coast. I think there's something very, very unique about the assemblage of fungi that you find across the arc of Texas, all around the Gulf of Mexico, and Louisiana and Georgia, for example, down the panhandle into Florida. But Florida, as we'll see later, is its own story. But the Gulf Coast, I think, with its sandy soils, its pine savannas that experience routine fire, the longleaf pine savanna is adapted for burning. So this is a place where you get a lot of fire influence, as well as these deeply lichenized, mossy, bromeliad-laden oak forests. Some of the most amazing oak forests you're ever going to see is all through Louisiana, Texas, Georgia, Alabama, and it has just like any oak anywhere, tons of mycorrhizal mushrooms that grow with it. So this is sort of the opposite end of the country now. Sorry for the geographic whiplash here, but something that I want to also highlight as being an important bioregion is the boreal forest. And what I mean by the boreal forest is this belt of trees, that cross Canada, and they sort of stitch together Maine and Cascadia. So far extremes of the continent are woven together with this uninterrupted belt of conifer trees. Very cold in the winter, wet, warm, mossy in the summer. So it's definitely a summer mushroom season up there. But here's an example of a species that really traces out the boreal forest zone. So unfortunately, the names of the photographers are not showing up here, but neither of these photos is mine. These are witches' cauldrons, Sarcosoma globosum, and they are associated with old growth coniferous forest. You'd have to go north of the Great Lakes to find these probably. But they are an emblematic species of the boreal belts. This is something that is, in my mind, the perfect mushroom to represent this bioregion. A bucket list mushroom for sure. I mean, just look at that thing. It's gelatinous, it's bizarre, and they're big. They're like the size of, softballs or basketballs. They're absolutely astonishing mushrooms. So if we were to follow the boreal forest out east, we would end up in what I think is also going to end up being an important bioregion, the northeastern maple, birch, and beech forests. These are the places everyone goes in the fall and October to see the color change. And this is what they look like, all sorts of deciduous trees, broadleaf trees. There are some conifers mixed in, some hemlocks especially, but all of these different broadleaf trees have interesting mushrooms associated with them. You get things like Leucofoliota, Cortinarius, Tricholoma, a lot of different boletes, an overwhelming number of boletes in these areas, as well as this cute little mushroom in the upper right that I include here as a piece of trivia. It looks like a Crepidotus, but you see that filmy white tissue around the edges of the cap? That is a partial veil. This is the only gilled mushroom that does not have a stem and also has a partial veil in North America, maybe anywhere. The only astipitate mushroom with a partial veil. That's a good trivia question next time you go to the local bar, right? They'll ask you, who was the pitcher for the Diamondbacks in 1973? And also, what is the only mushroom that has no stem but also has a partial veil? Okay. This is an example of a mushroom that traces out the northeastern.
How come we can't hear him?
Because I turned the sound on.
Can you hear me now? Yes?
You're good.
Did you miss anything? Probably nothing important. So here's an example of a mushroom that really traces out the northeastern bioregion. This is Leucofoliota decorosa, and you may notice there's a little red dot up there in the Yukon territories. What's that about? I don't know. It may be an echo of the boreal belt, but I did fact check it. This is an iNaturalist map. That's where I'm getting all these maps. And I did click on that observation and I looked at the photos and it looked pretty convincing. So it may be that we get these little scraps of clues of connectivity, gene flow across the continent that just show you that these boundaries, although they can be really strongly suggestive, are in the end permeable. They are blurry. There's outliers that extend the edges of these regions. There's no perfect representation of them. But a cool thing about this mushroom is that three people, Walt Sturgeon, Sam Ristich, and Gary Linkoff, they were sort of along the eastern seaboard from Maine to New York and down into West Virginia, I think. They lived in different places along the East Coast, but Sam Ristich would call Gary and Gary would call Walt and they would say, hey, I found Leucofoliota, go look for it this weekend. And they would all find it on the same weekend, all up and down the eastern seaboard on the same period of time. So it seemed to have this pattern of coordinated fruitings across the continent scale, which is pretty amazing. This pattern actually repeats in different species of mushrooms across the United States. But how exactly these coordinated fruitings are timed, no one really knows. This is an outstanding mystery to be pondered. But it's a fairly rare mushroom. It certainly should be on your bucket list. If you spend enough time in the Northeast, you'll definitely see it. It's not impossible to find. Okay, here's another mushroom that outlines the Northeast pretty well, but as you can see, extends much further south. And there's even that interesting dot in Southeast Arizona. right under the picture of the mushrooms. So what is that about? One single dot in Southeast Arizona of a mushroom that appears to be entirely Eastern. And it turns out, if you fact check that observation, that it's spot on. It's definitely that mushroom. What's going on here? So this is an example of what I meant by the echoes of the East that we find in the Sky Islands. And what's going on is that this is a remnant of a story from deep time, from deep sort of geological, ancient ecological conditions. And what was going on in the cooler, wetter climate that preceded human records is that there was a continuous belt of oaks that grew from the East Coast down along the Gulf Coast and into Arizona, into northern Mexico. It was much wetter, much cooler, more continuous forest. And mushrooms could disperse across this whole zone really easily. But then the climate dried out and a lot of that forest died back. And what we see now is what we call relictual populations, sort of barely holding on to fragments of their old range. And so in the high elevations of the Sky Islands, where it's still wetter and cooler, you get some of these populations still showing us what it used to look like. Still sort of whispering that this oak forest was once there. I went to that dot. I visited that place to try and look for this mushroom in Arizona, and I didn't find it. But amazingly, the place where it was found has all these other Eastern mushrooms growing there. So it feels like you're standing in a time machine when you're at this particular place in the mountains. Everything around you is an Eastern mushroom. You don't see any of the Arizona specialties. You don't see any of the Western mushrooms. It's all East Coast species in this one little campground. It's really amazing. Hen of the woods. This is a cool mushroom that doesn't circumscribe the Northeast. It actually circumscribes the East, but look how straight that dividing line is that separates the middle of the country into East and West. And this mushroom seems to obey that boundary with an almost spooky fidelity. It's like drawing a line straight north and south through the middle of Texas, and you get the hard boundary that limits hen of the woods. This is a mushroom that many of you have probably cultivated or even eaten. This is a delicious maitake mushroom. So it's all over the East, but it's really not in the West at all. Clearly something important is going on biogeographically with this middle of the country line. Okay, now here's a different bioregion. This is the Great Lakes bioregion, and I'm not sure how strongly this will be echoed by other species, but at least this very distinctive mushroom, which is called the leather veil bolete paragyrodon, is really only around the southern Great Lakes. I've never seen it. These images are from Ed's Buckthorn Control and Bolete Jones. I would love to find this species, but I have no chance of seeing it unless I go to its zone in the sandy, hardwood associated forests of the Great Lakes. A sort of similar bioregion, it's around the southern Great Lakes, but into sort of the middle of the country as well as the Northeast is delimited by the wrinkled peach, Rhodotus palmatus. This, I think, should be someone's state mushroom. One of the absolute must-see mushrooms in the United States. This is probably going to get a new species name. Rhodotus palmatus is a European species that looks very similar, but we have a slightly different variant here, grows on different trees, and it's genetically distinct. It's probably going to be Rhodotus reticeps, which means netted head, which is a very good descriptor. This thing definitely circumscribes something special. You can't just go anywhere in the East to find it. Appalachia. I mentioned the Appalachian Mountains right at the beginning, and I'm only briefly going to talk about them because I don't know much about them, but I can't imagine that they won't be one of the most important bioregions for fungi in the United States, partially because they are the only eastern mountains to speak of. So they're going to have a different character from the lowlands around them, but also because they act as a refuge for a lot of species that were pushed south by the glaciers of the Pleistocene. So when this North America was last severely glaciated, these huge sheets of ice, bigger than you can really imagine, I mean, they were truly stunningly thick and extensive, pushed a lot of species south because they made the northern United States completely barren, covered in ice, too cold for any living things to exist there. but then they retreated. Some of these places in the Appalachians, though, acted as little protective coves where the glaciers didn't enter. And these little remnant forests allowed for a lot of southern species to continue living in patches of refuges in these glaciated times. So you get a lot of different taxa, a lot of different mushrooms in the Appalachians and surrounding areas than you see in the rest of the country. This tree on the left is called sourwood. It's really an amazing species that you only ever find in the Appalachians pretty much. And little boletes like this Boletus curtisii. It's a species that extends far down into Mexico even, but its remnant populations are sort of in the foothills of Appalachia. So a few more eastern biozones that I think might be important. Atlantic white cedar acts kind of like redwoods in the sense that it's non-mycorrhizal, and it doesn't have a lot of mushrooms that grow there, but the ones that do are really distinctive. A lot of entelomas, orange entelomas, yellow entelomas, a lot of waxy caps grow here. Really boggy, acidic soil. The problem with them is that their wood was extremely valuable lumber, very rot resistant, and even the water where they grow tends to be very rich in iron. So early in this country's history, these trees were cut down for lumber, and the water, even in the bogs, was mined for iron. They would boil this water until they evaporated out iron precipitate, and they would use that metal. So there's not that much of old growth Atlantic white cedar left, which is a problem for mushrooms like this one. So these are photos by Bill Neal and Tom Murray, and this is one of the rarest mushrooms in the United States. This is Bellew's cedar tooth. It's a little relative, believe it or not, of Russula, but it's got a totally different morphology. We do have a species of Echinodontium here in California, but it doesn't look anything like this. And this is only known from 4 locations of old growth white cedar. And it's virtually extinct. You know, if you don't go to one of those 4 trees where it grows, you really can't find this thing because its habitat is virtually gone. Now, maybe it will come back as we allow for more white cedar forest to age into old growth, sort of old growth age classes. But right now, this seems to be sort of a dinosaur, a relict species that's barely hanging on. But it might argue for there being a Atlantic white cedar bioregion, at least for some mushrooms. Okay, now I want to talk about Florida as being distinct from the rest of the Gulf states, because it really is, I think all of us who've ever been to Florida or are familiar with it culturally, something special. It's a different sort of a place, not just from a human perspective. It gets tropical. It gets downright tropical in its southern reaches. And there are many mushrooms in the southern part of Florida that you don't expect to see anywhere else in North America. And I'm going to profile some of those in a minute here. But it's also got interesting trees like pigeon plum, cockaloba. So I'm going to briefly mention Gilbertson and Ryvarden. If any of you have studied polypores, they wrote a monograph on the polypores of North America, and they have this hilarious little statement. What's cool about their monograph is that they are some of the few mushroom taxonomists who've ever made an attempt to divide the country into bioregions from a mushroom perspective. And they provide a list of important polypore bioregions. However, they say, a brief descriptive statement is given for each region except for the tropical forest region of South Florida, which we are not attempting to cover because they were completely overwhelmed by it. They tried to profile the polypores of all of North America, and they gave up in South Florida because there's just so much different stuff going on, which is saying a lot because Gilbertson and Ryvarden were meticulous, total workhorses, and they still, it means something that they gave up on South Florida. Now we have some new polyporologists working in that region, including Joseph Vlasak, who I'm going to show you a few photos from in a second here. But perhaps the best candidate for a Florida state mushroom that I'm going to profile first is the flamingo chanterelle, Cantharellus coccolobe, which grows with pigeon plum trees on the beach. What does that look like? It looks like this. This is a tiny little pink chanterelle that grows in big troops under these pigeon plum trees, a mycorrhizal species that doesn't really have any analogs of any other tree in North America. You only find that, I mean, if you go to Costa Rica, if you go to Belize, if you go to Mexico, you find these beaches covered in this tree. It's all around the resorts, but it really doesn't exist in the United States except for South Florida. And this mushroom is common there. It was only described relatively recently. It was at first thought to be a variant of Cantharellus cinnabarinus, which is much more common in the Northeast, but this one is bright pink. It's a little bit of a different color and a totally different ecology. Definitely something to look out for if you go to Miami. Here are some of the polypores that we expect to find in South Florida that give it some of its special character. These photos are all from, well, two of them are from Vlasak, who is this modern polypore expert actually it's a father-son team. And then Ross Allen and I took a photo of Tomophagus colossus, which is this beautiful golden Ganoderma looking thing on the bottom left. But you won't even really recognize some of the genera. That's how different it is there. Abundisporus, Hexagonia, Pycnoporus, Ceroporeopsis, Earliella, Navispora, Rhytoporia. Those just don't sound like any of the mushrooms we find here in California. Nor does it sound like many of the polypores you see anywhere else in North America. Florida has something else going on. Up at the top there, Fuscoporia calomorpha. Vlasak claims that this is probably the most common polypore in South Florida. And then up at the upper right there, it's hard to tell from that picture, but that is a polypore that's only about as big as your pinky nail, and it grows on palm trees in the saw palmetto groves. There's also a totally different bolete flora in Florida. Pseudoporus floridanus is named after the state, and Oreoboletus abruptibulbus, that's Noah Siegel, my collaborator's photo. Jason Boland took the other photo. These are some examples of mushrooms you really don't expect to find if you're not in the extreme southeast part of the continent. Another one is Boletus rubris citrinus. This is a photo by Jared McRae. However, there is something interesting going on with this thing. There's a record from California. There's a record from Arizona. There's a patch in Texas that follows potentially some north-south river drainage. And then you get scattered records up the Northeast coast. It's not clear to me what is going on with this species. Something strange is shaping this pattern because it's so scattered, so broken up with seeming concentrations here, concentrations there. Maybe there's multiple species going on here, or maybe there's just some variable that we're not sensitive to yet. But these are the kinds of things we're going to need to think about if we come up with some descriptive bioregions. Last but not least, I want to show you this picture taken by bloodworm Richard Neal. This is the tropical red Leucopaxillus. First described from northeastern Brazil in that deep Atlantic rainforest, and found also in the vicinity of Gainesville, Florida, which is totally amazing. It is absolutely a bucket lister for me. The young caps are cherry red. They fade out to this sort of pinkish peach color, but a mushroom you don't expect to see anywhere else in the United States except for Florida. And it ties it to South America and to the Caribbean archipelago. I mean, talk about a unique part of the American assemblage. Last but not least, I'm going to mention Hawaii. This is the only, so in biogeography, there are some major world level bioregions. One of them is Oceania, which contains things like, Polynesia, New Zealand. And in fact, Hawaii is the only representative of Oceania that we call an American state, which just shows you how silly it is. These political boundaries don't mean much from a biogeographic perspective, but we said we're going to respect that biogeographic, we're going to respect that geopolitical boundary and bring it into it's a candidate for our attention. And Hawaii, I think, is unfortunately probably one of the most at-risk bioregions of mushrooms in the United States, like everything that lives there on land, and probably one of the most distinctive. And it's very poorly known. Dennis Desjardins and Don Hems spent quite a bit of time researching the fungi of Hawaiian Islands, and they published a book about it. Actually, let me get it out. It was reprinted recently, and I just got my hands on it. The Mushrooms of Hawaii. This is about the only book that you can get that covers Hawaiian mushrooms. So try and get your hands on it if you can find it. The old version is out of print and very expensive on Amazon, like ludicrously so. But this new one is printed by Echo Point Books and Media. That's where you have to find their outlets to get it. But the mushrooms of Hawaii are mostly represented, the special native ones, that is, are represented by a lot of waxy caps, quite a few stinkhorns, and this mushroom in the bottom middle here is Rhodocolibia palahuana. So they've all got cool Hawaiian language names. So they gave species names that were actually in the native Hawaiian tongue. So they're kind of difficult to pronounce, but they're really evocative and often have interesting meanings. But these are mostly in the high elevation mossy forests. Down low, there's been a lot of invasive species, just like the rest of the biological story of Hawaii. A lot of non-native trees, a lot of non-native mushrooms, and it's only when you get into these native forests in their remnant patches that you start to see these special species. But I suspect that they are at risk, and I think they really deserve more attention in the next decade before they disappear completely. It would be nice for people to make Hawaii a more active research focus than it currently is. Just yesterday, I believe, was the first annual Hawaii Mushroom Festival run by a friend of mine, Ben Lillybridge. And if you are interested, you should get in touch with him and keep your radar out for the annual Hawaiian Mushroom Festival, which they're going to be hosting hopefully every year now. So I've now taken you on an extremely whirlwind tour and very speculative tour of what I think some of the important bioregions of mushrooms might be in the United States. But I want to stop now. That's sort of the end of my slideshow. And I want to talk to you, if you have any questions, about what you think other bioregions might be worth nominating or mentioning from a mushrooms perspective in the United States. So it's a little bit late now, but hopefully you still have some time to stick around and ask, because I'd love to talk to you more about it. But thank you to the LA Mycological Society for having me tonight. And I hope you learned something about biogeography of fungi.
Thank you very much. That was great. I love those maps. Were those all derived from My Naturalist?
Yes, I should have mentioned that. All of those maps were from My Naturalist.
Do you have one where they're color coded with all the different regions of the mushrooms in different colors?
I wanted to make one like that, but I decided that I didn't have enough clarity about the boundaries of some of the regions. But that is the goal, to produce some map that contains at least a first pass guess as to what those regions look like. So hopefully I would assemble something like that in the next year or two.
Love to see it. That'll be great.
But it's going to be crowdsourced. You're going to have to help.
So any questions? Let's look in the chat too and make sure. I'm seeing a lot of thank yous and wonderfuls.
Looks like Aaron Thompson linked to the Instagram for Ben Lillybridge's organization, Malama Mushrooms, which is the group that runs the Hawaii Mushroom Festival. Is there a question from Jennifer? Raised hand.
Yeah, I do. I was wondering, do you expect these bioregions to become more diffuse or more sharp as like more mycophiles mapped via tools like iNaturalist?
That is a really good question.
Because right now I'm assuming we don't have a great map just because it's like, not enough people know about it or know how to use it.
Right. This is actually a hard question to answer in a simple way. The only direction that more data can take you is to reveal the accuracy of or the reality of blurry boundaries, right? If you had a perfect picture, you would see just how blurry everything is. So I think the only thing to expect from more data is less sharply defined boundaries. But if you zoom out enough and if you use a consortium model where you use multiple species to represent the region you're talking about, you might be able to find some very sharply delineated natural bioregions. And that would take a little bit of math to do, a little bit of computer modeling, but it certainly could be done. And you might end up with some actually remarkably sharp boundaries that way. Someone asked, what about coastal areas, salty grasses, tidal areas? Absolutely. I don't want to survey it, but someone should. Anytime you get these very intense habitats, salt, desert, ice, you end up with a smaller set of species that live there, but a more distinctive set, if that makes sense. And someone's going to have to do that. There are these big desert regions that don't have many species, but that doesn't mean there's no mushrooms there. It just means that they are the mushrooms that sort of are in the gaps. They're the connective tissue between the biogeography of the other species. There's always something there. How have I seen biogeography used in conservation? Sometimes it can highlight your conservation priorities. So for example, Hawaii. Once you identify that a place has very special at-risk species, it can sort of jump up in the priority list of the organizations that are empowered to do anything about it. However, I don't think they're that useful. I have a sort of a different take on fungal conservation and conservation in general, but we won't get into that right now. But to answer your question succinctly, it can sometimes highlight your priorities. It can be a way of ranking where you're going to put your efforts. Would Mount San Jacinto outside Palm Springs be considered a sky island? I think, okay, so the answer is no. It's not typically considered a sky island, but I don't think that means that it shouldn't be. It is definitely a distinctive unit of life, of living creatures. So the Jepson Manual is the sort of massive tome of all of California's vascular plants. If you're ever a botanist in California, you use the Jepson Manual. It is the best botany manual for a single state that we have in the entire country. And the Jepson Manual does a really good job of breaking down just one state into bioregions. So there's like, dozens of bioregions of plants in California from the Jepson's perspective, and it identifies Mount San Jacinto as one of those bioregions. It has a separate bioregion just for the San Jacintos. It's the smallest bioregion in all of Jepson's breakdown. So clearly the plant people think that San Jacinto is an extremely special place. No reason to believe that it couldn't be similar for fungi. Okay, someone is talking about living in Flagstaff. The local society, Arizona Mycological Society, often comes up with desert fruiting fungi from the Phoenix area. A lot of it may be landscaping introductions, but some of it is true desert manifestation. It might be interesting for you to contact our society and see whether the fungi is of interest. I am definitely interested in talking to the Arizona folks. I'm actually teaching a class in the Sky Islands this upcoming August. If you are interested in joining, you can email me. I'm going to put my email in the chat here, but it's a 9-day course in the Sky Islands of Southeast Arizona. We expect it to sell out and to fill up pretty quickly. So if you want to go, if you're interested, definitely email me soon. Okay, excellent question from Carissa. I've just started using iNaturalist. I'm just learning to navigate it. Is there a specific project I can join, or do I just document whatever fungi I find and it will be added to the data accumulated? Thankfully, the latter is the correct answer. You don't need to do anything special other than what you're already doing, which is just share what you're finding. That's all you have to do. Everyone who studies this sort of thing will have access to that data afterwards, and it will be easy enough for them to find the data and incorporate it into whatever sort of model building or mapping they're doing. So no special steps necessary.
Okay, sorry, I got kicked off of Zoom like right as you started, so just no necessary steps.
Nope, just
Okay.
use it. Just
Thank you.
use it to share, and that's good enough. Yeah.
Cool, thanks.
Hey, Christian.
Hi.
I'm wondering, is there any point in time where an invasive species all of a sudden becomes natural? Like, certainly plants have invaded other areas in the past, and we think of them as the local stuff. So has that been thought of in mushrooms or maybe even plant life in general?
Yeah, so maybe the process you're referring to is some plants are considered naturalized when they start setting up self-sustaining populations, even after human introduction, which is a little bit different from natural invasions. So there are introduced mushrooms that are invasive fungi, so something like the death cap or something like Agaricus xanthodermis, and they're definitely naturalized. They're totally self-sustaining populations here now. At what point in the future will we consider them just part of the native assemblage? I have no idea. That's going to be a fascinating question for biogeographers and ecologists going forward, because at some point they're just going to have been here for a very long time. And even though we know that their deep origin was anthropogenic, at some point you're going to have to sort of lose that prejudice against them and decide what to do about your conception of them. But in the meantime, we do worry about invasive species as a major mechanism of endangerment for native taxa, for local species, because they tend to be quite aggressive and dominate real estate and resources that would otherwise be sort of more finely divided between native species.
I know from exploring caves that graffiti becomes historic at 50 years. So if the graffiti can survive for 50 years, then it's no longer graffiti.
I love humans. We just have all
Yeah.
these nice, neat little boundaries about sitting there watching our clocks, and one day you're unhappy, the next day it's historic.
I have a question. So in some of these bioregions that you've described, will the reintroduction of species like chestnut that have been wiped out in the United States bring certain species out of dormancy? You mentioned like rebuilding white cedar and other things. So maybe this is just a general question about dormancy and like ungerminated spore life in the soil and whatnot.
That's a really good question, and the chestnut is an awesome example. So I didn't even realize personally how radically the eastern forests changed when American chestnut, died out, which was relatively recent. I mean, this is just outside living memory for Americans, by a generation or two. This was a dominant forest tree across the East Coast. So many American chestnuts died due to this chestnut blight that arrived from Europe, wiping out one of the dominant hardwood, mycorrhizal hardwoods of the East. There's nothing left. So it went from being a dominant tree across the East to zero, presumably taking all of its mycorrhizal associates with it. Some of them may have been able to continue living by growing with oaks, which are not the same species as chestnut, but they're in the same family, so probably a suitable proxy or surrogate host. But probably some things were more closely tied to the chestnut themselves, and those are probably gone, but they may persist in the soil, like you said, in the form of a spore bank. No one knows. And if they are successful at propagating out the chestnuts that are currently sort of being bred for disease resistance and replenishing sort of a forest that is dominated by chestnut, I mean, certainly one of the number one things to monitor would be what happens after 50 or 100 years. Are there mushrooms that sort of awaken from their long slumber and find their old host again? That would be, it'd send chills up my spine if that was the case. There's a question about what is the most ubiquitous invasive fungal species I see in my research, and the answer is death caps. From a North American perspective, death caps are our number one most rapidly spreading invasive species. It was just recorded. So they were introduced to California in the 1930s or so. They spread really rapidly north and south from there. So now they're all the way up in British Columbia. They're all the way in San Diego. No one has yet recorded one from Baja California. So if you go down there wine tasting in the Valle de Guadalupe in winter, you could record Mexico's first death cap. I'm sure it's already there. But someone's got to document it. It also grows all over the East Coast now. And just this summer, it was recorded for the first time in Wyoming, which is the first place that it's been found in the middle of the country. So this is a mushroom that's really increasing its presence all throughout the United States. So the general question here, how do I see climate change affecting bioregions? It's all over the map, quite literally, to use that metaphor. It changes things in ways that are unpredictable, and it changes things really rapidly. And even trying to circumscribe these bioregions feels a little bit futile, given how messy everything's getting. Things are changing at a speed with which it almost evades description. You're sort of aiming at a moving target and trying to outline what the past was like as it's becoming the future. That was already the case even 100 years ago, because biogeography is never static, but right now it's even more intense. So we're still going to try it, but it's a particularly silly time to be engaging with this practice for the first time. Any last questions? I know it's closing in on 9.
Hi, Christian. I'm not sure if you answered this one or not, but I was wondering if you have any general theories about these like one dot outlier mushrooms, like where they're found so far away from where they usually are spawned, and verified as well. If it's not unlike animals carrying seeds of plants, so if humans could be carrying spores or spawn with them to wherever they go back.
That's a good question. And our first explanation should always be data deficiency, that we just haven't gotten enough observations, and that we would expect over time to see a few more filling in the gaps between the core range and the outlier. However, that's not always going to happen. Sometimes we will end up with these legitimately isolated, really disjunct single dot occurrences. And yeah, absolutely, there's reason to believe that in some cases, human transplantation could be the source of those outliers. But in other cases, it's going to be much more mysterious and hard to describe. Sometimes it'll be in the middle. Sometimes we'll have a good theory that we assume is the reason, like a relict population from a different paleoclimatic condition. But your guess is as good as mine for some of these.
For a mycorrhizal species, I mean, doesn't the tree have to be there?
Yes. So for mycorrhizal species, you almost always default to the explanation being the presence of the tree. So sometimes
so it's going to mimic the distribution in those cases, and those are probably going to be the easier ones to figure out.
Obligate associates of trees are always the easiest ones to map because they are so closely tied to a particular host. But what's interesting is that if you think of the host as a potential space of occupiable map region, not every obligate associate fills the map of its host entirely. Sometimes they have a different variable that constrains them from filling their whole potential range. In ecology, we call that the realized niche versus the potential niche. And anytime you find a mismatch, it tells you that something interesting is going on. Okay.
Any other questions?
Thanks for the great questions.
I'd like to thank Christian again for a wonderful talk. Really interesting study there, and hope to hear an update of it before too long.
Yeah, well, don't leave me to it. You got to help. Y'all have to get out there and help me map these mushrooms.
We will.
Alrighty.
I've heard a lot of interest recently. Well, thanks again, everyone.
Sure thing. Bye, everyone.
Thanks again, Christian. Great
Enjoy
talk.
your evenings.
We'll see you later.
Bye.
See you.